Greetings, mathematicians. In this video, we're continuing our work with simplifying radicals. So we're going to be combining all of the different rules that we've learned so far, such as our product and quotient properties. Now, you might attack these in different orders, and that's fine if you've tried these and you come up with different work along the way, but you should come up with the same answer in the end. So for this problem, I might look at this, and the most obvious thing that I see right away is the fraction. So I'd probably be tempted to start by breaking this up using the quotient property. From there, I see that thankfully the denominator works out quite nicely. Square root of 49 is just 7. Numerator, square root of 20, that doesn't work out nicely, but it does have a prime factorization. 20 breaks into 2 times 10, and 10 breaks into 2 times 5. From there, I've got some things that come in groups of 2, so I know that I can simplify this further. And then my final answer would be 2 root 5 over 7. For the other problem, for example 10, I do have a fraction, but the 4 in the denominator is not part of what's inside of the radical sign. It's not part of the radicand. So I'm not actually going to be doing anything with the 4 right now. I'm going to be concentrating on the root 20. Now, thankfully, I already did some work in the previous problem where I simplified root 20, and I know that that root 20 simplifies into 2 root 5. So I don't have to do that work again. Now, what's interesting here is that this problem is not actually completed yet. Something you'll notice here is something you might already know about fractions, is you might see this 2 over 4 here. And you could rewrite this as 2/4 times root 5. You don't necessarily have to write out that step, but it helps some people to see this a little bit better. And you know that 2/4 simplifies to 1/2. And you could think of the root 5 as root 5 over 1 if that's helpful. And then when you multiply fractions, you know that you multiply across the numerators. So 1 times root 5 is root 5, and 2 times 1 is 2. So actually our total simplified answer here is root 5 over 2. So one thing that you'll have to look for is that sometimes after you're done simplifying the radical part, sometimes you might have a numerical part with the coefficients that also simplifies, such as this 2/4 part that simplifies to 1/2. Here are a few more problems. If you feel up to the challenge, I think you have all of the tools now that you could give these a try. So if you want, go ahead and pause the video, give them a try, and then come back to check your work. If you're not quite ready for that, we'll work through these together. So example 11 is just a product property question. Remember, for these, we'll start by finding a prime factorization. So prime factorization of 212, or 112 rather, is 2 times 56, and then 56 is 2 times 28, and then 28 is 2 times 14, and 14 is 2 times 7. And then from there, if I start next looking for things that come in pairs, things that are in groups of 2, that now gives me square root of 2 times 2 times square root of 2 times 2, and then I have the 7 left over. So square root of 2 times 2 is 2, square root of 2 times 2 is 2, square root of root 7 is root 7. So this simplifies to 4 root 7. For our next question, we haven't done one yet here that had a coefficient. So what we'll do here is basically we kind of just carry that coefficient along until the end. So we're just going to concentrate on the root 28 over 9 first. So that's our quotient property. So break that into root 28 over root 9 and just leave the 6 times part in front first. You could think of that as 6 over 1 if that's helpful for you, knowing that we're going to end up multiplying fractions a little later on. 28 is 2 times 14, and 14 is 2 times 7. So using our product property to start simplifying the numerator. Denominator, luckily, is just a nice perfect square. Square root of 9 is 3. Now, if we'd like to start putting this together a little bit, when we multiply fractions, we multiply the tops. So 6 times the top would be 6 times, we've got our pair, we've got our singleton. In the denominator, 1 times 3 is 3. And then root 2 times 2 is 2. And then depending on when you happen to notice it, here we have something that is going to simplify. If we have 6/3, 6 divided by 3, I can factor out a 3 there. 6 divided by 3 is 2, 3 divided by 3 is 1. So if I'm reducing fractions like I did way back when, I can do that here. And then in the numerator, I've got 2 times 2 times root 7, so 4 root 7. And then in the denominator, I just have a 1. I don't really need to write that 1. Anything divided by 1 is just itself, so 4 root 7. Now our next one, root 76 divided by root 25. I'm going to use my quotient property. Square root of 26, or 76 rather, that is 2 times 38, and then 38 is 2 times 19, and then thankfully square root of 25 is just 5. In our numerator, we've got our groups of 2 and our singletons. Square root of 2 times 2 is just 2. And just a quick check here, 2 over 5 is a fraction, that's not going to reduce. So we just have 2 root 19 over 5. All right, and then for our last one, again, there's lots of ways that you could attack this. One thing that I would look at here is combining my product and quotient properties, but somewhat in reverse, and knowing that, for example, the square root of AB is the square root of A times B, and the square root of A divided by B is the square root of A divided by the square root of B. What that tells me is that I can take these values, the 12, the 18, and the 3, and I can multiply and divide them to put this together into a single value. And sometimes that is just easier to work with. So I think what I might do for this one is start off with that. So I'm going to do 12 times 18 divided by 3, and I'm going to get 72. That way I'm not dealing with 3 different radicals that I have to simplify all on their own, and I'm starting off with just one single value. And from there, use my prime factorization and my product rule and break this down into 2 times 36, and then 36 into 2 times 18, and then 18 into 2 times 9, and then 9 into 3 times 3. and then look for my groups of 2. And then use my commutative property to reorder those. Square root of 2 times 2 is 2. Square root of 3 times 3 is 3. And come up with 6 root 2 for my final solution here. All right, so that is where we will call it a day for this video, and we'll see you shortly.